Hey, Sloan, you're getting a preview of the new intro right there. Good to see you. Let's throw 100. Maybe do 100 points in office hours, right? Good to see you here, Sloan. Whatever questions you got, we can start doing. I was going to send some announcements to people. I was doing them in the background. I saw you in the chat right there. Gonna send out some announcements. Say, swing by the office hours, get some work done. Let's see right here. Let's send out a few announcements. Let's go over here and say office hours starting. Swing by office hours on Monday, Tuesday, Wednesday, or Thursday. Always send announcements, so you can find them in the playlist on the homepage. You can also click this link to join today's. Okay, click here. All right, Sloan, if you got questions, let me know. I'm finishing this announcement. There it is. That's going out to 320. And then, okay, we can talk about the lab or the assignment. Okay, there's that. Office hours starting. And Sloan, whatever questions you want to do, let me know. And then there's that one. Office hours starting. Copy, paste, copy, paste, copy, paste. There we go. Hey, what's up, Andrew? Let's throw some 50 points. Jim Marcus, good to see you here too. What questions are there? Oh, and if you're here for last office hours, I guess I got to show this. I think this is this the right one? I think this is the right one. Okay, let's check it out. Here, let's show something right here that we got working. And then you were awesome. Check this out. Okay, so this right here is my app that I created last time. Did I put an install thing on it? No. Okay. Whoa, no, I put install. No, don't install packages. I don't want to install the packages. Stats not found. Okay. Oh, because I was making the assignment for 320. So for 320, but name your favorite player. I don't think I showed this in class like this. I don't think I had it fixed 100%. So let me, this is just a small comment on BS 320's upcoming assignment. They're not doing something exactly like this. So if you're in 320, don't be like, wait a minute. BS 320 upcoming assignment, week 2 assignment /lab. And tool 1, draw some questions. Deeply understand quantitative and categorical. Tool 1, right? With tool 1, how to display the data, how to summarize the data, how to graph the data. So think about this right here. We have Drew Brees right here. Do you know what the name of these graphics are? I think we mentioned this a good bit in the first class. So think about this. We're looking at Drew Brees' completions in a game. So his completions would be like how many completions he gets is a what variable. How many completions he gets is a what variable. How many completions he gets is a what variable. I got some iced coffee today. So we're bringing this back to the idea of 201. How many completions he gets is a what variable. So in like one game, he gets 15 completions. Started in 2001. So how many completions he gets is a what variable. Oh, no one knows. I've stumped everybody. Well, it's not identifier because we don't identify things by amount of completions. Is it categorical or quantitative? How many completions? And then you could compare 2 games. You could say in this game, he got 20 completions. It's quantitative, Andrew. Good answers right there. So what kind of graphic am I showing you? I'll put up the hints on the screen. There's the hints. You can pause right there if you want. What kind of graphic am I showing you? What kind of graphic is this? There's the answers to the combinations. And you can see the y-axis has a quantitative completions. Now, seasons are kind of quantitative because you can be like, these are 2 seasons apart, but we're using it to group it. So in this sense, we're not doing quantitative differences. So what is this graphic called right here? What is this graphic called? What is the name of this graphic? If anyone wants, they are box plots. If anyone wants to ask questions for free, I'm ahead working on chapter 3 assignments. Oh, we did some chapter 3, data analytics 2 univariate. You want to do that? We'll do data analytics 2 coming up here next. Let's do it. So right after this, we'll do data analytics 2, Sloan. First question from Sloan, data analytics 2. We'll do it in about, I'm going to put timer on Sloan just in case I get distracted. My timer is a 2-minute timer. So in 2 minutes, we're doing data analytics 2. Let me take the timestamp right here. 8:23, stat tool 1, data analytics 2. Okay, we got it in the thing. Name a question from chapter 2 homework, Jim Marcus, and we'll do it. That's how it works. Just drop a question in, and we'll do it. So what we could do, and I'm going to do this real quick. So there's Tom Brady, and we could change the statistic we're looking at for them. We can change the stats. That's what I like. But we might be able to easily go down here to our graphic that we created. Let me try GG histogram. Okay, will this work? Will this work? Oh, no, stat bin. Maybe it's because... Let me try Brady. Oh, man. The GG doesn't work right there. The GG histogram doesn't work. But it's probably because the grouping variable fill equals season metric. So we might just go here and maybe try this. Let's try one last thing. Oh, he did? Oh, well, yeah, I mean, you got it. That's a bummer. Sad times right there. But I was trying to do some, sad day right there. Well, you know, he played how many seasons? Like 22 seasons. I mean, he holds so many records. So legend right there, Tom Brady. Shout out to Tom Brady right there. Something's going on with the GG histogram, but we could make histograms of it. We could look at the differences between seasons, but trying to change some code on the fly. So shout out to Tom Brady right there. Very relevant thing to talk about today. Let's go do that. Data analytics. And Jamarcus, drop any question you want into the chat and we'll do it. Say, can you do this one right here? Just name the question and we will do it. Okay, data analytics 2 is the first thing asked about. It is cold and flu season. Gotta stay strong. Okay, we got data analytics 2. Let me see the time on it. Mubot is awake. There's the bell. Perfect timing. Let's go do it. Okay, data analytics 2. I have class. I'll be lurking. That's cool right there, Angela. Sorry, 20 points for lurking. So here we are with data analytics 2. Now, a lot of people don't know this, but the file extension tells you what program it uses. So it's called a file extension right there. You might be like, well, I know that, Brian. Oh, okay. I'm arguing with the person who's watching the video in the future. But .jmp means it's opened in Jump. So all these files you see down here that I have open are usually .jmp files. It's not a file, but there's some JMP files right here, like the Survey 2001 jump data right there. So we got the Survey 2001 jump data. Woohoo! Okay, so the first thing you need to do is take a random sample of this. So with this, make sure you take a random sample. Need to take a random sample. You don't have to take a screenshot of the random sample. How will you know, and I want to point this out to everyone doing this, how will you know how you are graded on this? How will you know how you are graded? If I was you and I was doing this, I would complete it, and then I would look at the what step by step. How will you know how you're graded on this? The rubric. The graders literally, when they're grading, I wish I could grade one right now, but the graders literally just go click, click. And then if you have questions, let me know. Great job, Mozzie, right there. I'll throw more points. Make sure to ask about, like, if you disagree or like, hey, Brian, I did this. You said do this, and I did this. You can always question your grades. And if you don't have me as your instructor, talk to your instructor too. They're very open to like, oh, wait a minute. I thought I got the points here. I thought I did what was asked. Hopefully Brian didn't lead you in the wrong direction. That rarely happens, but I've been teaching 13 years. I've made a mistake and told someone something incorrect every once in a while. I'm like, typo error is this. And they're like, whoops, you reversed it. It happens. So with this, look at the rubric once you complete or while you're doing it to make sure you're following the steps, because that is literally what the graders are going to look at while they're grading you. So we see we have to make a bar chart, a pie chart, and a histogram. Okay, so think about this. Bar charts are used for what kind of data? Bar charts are used for what kind of data? Bar charts are used for what kind of data? These are notes you want. Some people say, what should I be learning? Bar charts are used to display what kind of data? You could say 2 words. A bar chart is used to display blank, blank data. A bar chart is used to display blank, blank data. A bar chart is used to display blank, blank data. You're right. And I always go to my friend Marshall Erickson on this. So categorical univariate data, one categorical variable. So here is a pie chart of his favorite bars, and here's a bar chart of his favorite pies. So if you ask someone like, what's your favorite pie, which is a categorical question, you could make bars from it. If you ask people, what's your favorite bar, you could make a pie from it and find out the percent of people, or maybe he's looking at which bar he went to that night. You could record, tonight I went to this bar, last night I went to this bar, and that'd be a categorical recording right there of how often, the frequency of which you go to the bars. Now you might say, but isn't that quantitative? I went to this bar this time. But think when you record the data, you'd be like, okay, tonight I went to Half Barrel. So although you would get a count or a relative frequency, that's relative frequency pie chart. A relative frequency pie chart in percent of awesomeness. He would have to go by percent of time he went. Like if you're rating them by awesomeness, that would technically be like quantitative. So How I Met Your Mother, got to get your stats right. And then his pie charts right here I think he has by tastiness or something on it. But it would have to be like, he would have to see like how many times he ate that pie, and like he would have to record, tonight I ate an Oreo pie. So Marshall, tell it better than me. Go ahead, Marshall, take it away.
This is a pie chart describing my favorite bars. And this is a bar graph describing my favorite pies.
Now, the reason I like this video so much right here is because I want you to forever link the idea of bar charts and pie charts. When you hear a bar chart and you hear a pie chart, you should think they display the same kinds of data. Bar charts and pie charts, look at the arrows right there, display univariate categorical data. And another clue we have on this right here that really tells us we're displaying the same type of data is that if you look right here, you'll be using this variable for the bar chart, and you'll be using this variable for the pie chart. So that's like, wait a minute, it's the same variable. It's just a different way of displaying it. So we could display it in a bar chart, we could display it in a pie chart, we could display it in a Pareto graph, Pareto chart, Pareto plot, whatever you want to call it, bar chart put in order, frequency table, which we'll put on the bar chart, or a ring chart, which we're not big fans of here. Now the histogram is different because histograms display what data. These are keynotes. We're trying to make sure we learn what we need to know with this, the things that'll be on the test. Histograms display what data. Histograms display what data. Histograms display what data. We're seeing a bunch of histograms on the screen right here. A lot of histograms. Talk about shape, center, spread of those histograms. So histograms display what data. A histogram displays what data. More importantly, histograms are always this, but a singular histogram means we're only talking about one variable, quantitative, and univariate quantitative. Univariate quantitative. Great job, Sloan, right there, and Mozzie right there. So that's important to know. We can do things like stacked histograms. So stacked histograms, I'll show you them really quickly. That's when you add in another variable and you stack by that histogram. A stacked histogram is going to look where you take something like gender, and you go right here to high school GPA, and then, well, these are side-by-side histograms, I think now. Wait, where's my histograms? Those are side-by-side histograms. Here, let's start over. I'm going to put gender right there, and then I'm going to put high school GPA here, and now we have more stacked histograms right there. So there is what we call stacked histograms, but we're still displaying people's high school GPA. That's the variable of interest we're talking about, but we're stacking it by gender right here, so we can do a comparison. You can see that's probably me down here at the very bottom. So with this, I joke, but I'm being kind of serious. Now that we know what we're doing, we're displaying categorical data and we're displaying quantitative data, we need to take a random sample. So let's go ahead and put a note in the video right here. Let's put this on theory, and then let's go here and talk about random sample. So Stat 201, Data Analytics 2, random sample. Well, I guess I'm marking this, but it's pretty easy to take a random sample. You go to tables and you go to subset. So I'm under tables, subset. If you're on a Mac, it's going to be all the way at the top. You have to click the little bar that kind of disappears on the Mac. On the PC, just go up there. I think sometimes it hides the bar too. Maybe they changed that in Jump so it doesn't do that anymore on all PCs. But make sure you go to the top of the screen when the window is active. On a Mac, the window has to be active. So if you're over here on something else, make sure you have the active window on the Mac on Jump, and then go to tables and subset. Now that you've found this, go ahead and type right here 400 plus the last two of your UTID. So you'll type in like 4. Don't type in the number I'm typing in. So what should those last two numbers be for you? What should those last two numbers be for you? Make sure to read the instructions. You're not typing in those numbers right there. You're not typing in those numbers right there. I mean, you might. There's a 1 in 100 chance you are. There's a 1 in 100 chance you're typing in those numbers. So you type in a 4, and and then you type in the last two of your student ID. Great job, Sloan, right there. So make sure that's for 1 in 100 people. That's going to be their answer. So here we go. Now that you've done this, you will see down here on the bottom your random sample size. Now, if you look, the identifier is randomized, so everyone's going to have different results with this. So it's virtually impossible. Like the one time we had students turn in the same random sample, and they were like, I guess we just had it happen. I saw my friend put in that ID, and I put it in too. And then we ran the mathematics, and I think I found you have a higher probability of winning the Powerball 10 times in a row than getting the same random sample with this large of a data set. It's literally take 806 observations and pick 499 random ones of them. So if you look at the combinations of that well, watch this. I'll tell you the answer of it. It's really easy to do over here. It's choose from, so there we go. We're choosing from 806, 499. That's the probability right there. Might be, I can't remember what that's. Yeah, it's Powerball at least like 3 or 4 times. Because probability winning the Powerball is like 1 over a billion, maybe. That's 1,000. There goes that. Yeah, so that's Powerball probability. Powerball. So the probability of winning the Powerball twice in a row is this. Oh yeah, yeah. Probability. Oh man, it's like you're winning the Powerball every day almost for a month. So the chart you wrote for you, the histogram top box is univariate quantitative in the box chart on the top right is univariate. Which, oh yeah. Yeah, this one. Okay. So the top left, so this is what Sloan's asking me to it. Here is univariate quantitative data. You see how on the left there's no variable on, it says X variable and that's blank. So there's no secondary variable here. Everything here and here is univariate. This is univariate quantitative. This is univariate categoricals because there's no secondary variable. The Y variable is quantitative for everything here. Right here, the Y variable is categorical, and when you reach these regions inside of here, everything where I'm blocking and touching right now, these are all the bivariates. So a scatter plot uses 2 what variables. So a scatter plot uses 2 what variables. A scatter plot requires 2 what variables. A scatter plot requires 2 what variables. A scatter plot requires 2 what variables according to this graphic right here to make a scatter plot. Not 2 x variables. So the x variable will be what right here. So look this way, and the x variable will be what? So you always have like an x and a y. Your x variable will be this, and your y variable will be this. So if you want to see what the x, 2 quantitative variables, does that make sense? A scatter plot requires 2 quantitative variables. So to make side-by-side box plots, my x variable should be what? To make side-by-side box plots, my x variable should be what? So, yep. So x will be what? So x for side-by-side box plots, x will be what? And then we'll see this here in a moment. For side-by-side box plots, my x will be what? So you want to look this way for the x. The x will be what type of variable? So you go across this for the x. The x will be what? Categorical. And then the y will be what? So this is the last question right here. The y will be what? So the x will be categorical. Y will be what? And then we'll see this in action. Understanding this is very important. And then writing it down and practicing and understanding box plots are quantitative. That's a hint right there. Quantitative, exactly. So watch this. Are you ready? And then we're going to start making the graphics. Here we go to the graph builder. And we put an x variable that is categorical, and then we put a y variable that is quantitative, and guess what we just made? Side-by-side box plots, because a quantitative y variable and categorical x's. Now, we could have just made box plots by not using an x variable, so we could take out the x variable right here and just make a singular box plot where this is just a box plot. It's just a quantitative y. There's no x. Does that make sense? Now we're not breaking it apart and putting it side-by-side for categories. So side-by-side box plots are when you add in another variable right here and make it a bivariate graphic where now we're breaking apart on the x-axis based on a category. So now it's no longer a box plot, it's side-by-side box plots. They're just side-by-side. Does that make more sense, Sloan, right there? So that's where the change in the names of the graphics are. Like this is a side-by-side box plot versus a singular box plot. And great job right there, Andrew and both Sloan. So let's start making the bar or pie, right? What was the first one? A bar or a pie? And then Jamarcus, let me know which thing you want to do next. So let's talk about that bar or that pie. Statue of 1. Data analytics. 2, and was it bar or pie first? Bar or pie? It is a bar chart. Okay. Bar chart. How does Terry suggest making it this semester? Okay. Here it is. Let me read it because once in a while I miss a little thing. Tell me if I miss something. You get that 100-point button if you correct Brian. So correct Brian every time you think you need to. You get 50 points if you don't correct me. If you try and you're wrong, you just can't try every 5 seconds unless I'm making mistakes every 5 seconds. Create a bar from the variable family order using analyze distribution. The bar chart must be in the horizontal layout. We'll do that. Display options include the values, either show the counts or the percentages above the bar. Take a screenshot of this and then include a short write-up of the different levels in ascending order. So ascending means going from lowest to highest. Descending would go from highest to lowest. Be sure to include the corresponding values. So the most common mistakes I see, I'm going to highlight right here the mistakes I see in making this. First off, here's the mistakes. Are you ready? It's a very important thing in your write-ups and what you do. The most common mistakes I see are 1, it's not in horizontal layout. 2, people don't include values. Screenshots are sometimes bad. People take a really bad screenshot. And then we need to have the bar chart and the frequencies. Okay, so I know how he wants it done right here. And then the short write-up, people don't do ascending order. So ascending is going to go in orders from like 1, 3, 8, 10. So make sure you go in ascending order right here. So low to high. So you want to go from low to high. And it doesn't hurt to just write a little bit more. So these are the key things we need to look at. I'm going to talk you through this right here, but let's make the graphic and see what we get. I think that's everything. Good to go. Okay, so to make this, and please note, and everyone, please type this in the chat for 50 points. Brian is doing a different variable. Yeah. Which one do you want us to do, Jamarcus? Let us know. Be like, well, we can do some homework too. So yeah, I'll do homework too. Let me put that on the thing right here. But please type this in the chat. Brian is doing a different variable. People need to know that because some people will directly copy what I'm doing. Thank you, Sloan, right there. So some people will directly copy what I'm doing. I think they listen to these videos or they don't listen to them. And I'm like, I'm doing a different variable. And then they'll lose a lot of points because they're like, oh, I just click what Brian clicks. Every time I do this, I'm always going to do something a little different so you can follow along. But then you have to go through and be like, okay, well, how does this relate to what I'm doing? A lot of times I won't write it down too because I want you to write it down and kind of interpret it. That's where the real learning takes place. So you're not directly copying what I'm doing. You're just kind of seeing how to do it and how we would interpret it. Okay, so with this, we're going to go here to Analyze Distribution. Analyze Distribution. Under Analyze Distribution, I'm going to take Relationship Status. Relationship Status will now be put into the Y columns. You can tell this is univariate because we're only doing one variable. You can tell it's also categorical because it's got the red right there. Blue is quantitative. So we're analyzing one categorical variable, and what do we get? We get a bar chart. Now, there's one problem right here. This is not in horizontal layout. To make it in horizontal layout, I like to go here to the option. Let me zoom in so you can see it a little bit better. Here you go. So you go to the second red arrow and go to histogram options, and you go to first red arrow. Sorry, I stand corrected. Go to the first red arrow and go to stack. You want to go to the first red arrow and go to stack. Once you click there, it'll stack it, putting in horizontal layout. Now, I do like to make some changes to this. These are things you don't have to do, but I like to make it look nice. If you notice there, the text is going off the screen. Really don't like that. That is going to be interesting. So what I'm going to do, I think yours won't. You won't have this problem. Oh my gosh. Okay, wow. This is a change where you have to double click. You're probably not doing this. You're doing family order, so you won't have this issue. And I double clicked that. You don't have to do this. I just don't like that text. Oh, look at this. Casual dating. Man, that's nice. Exclusive dating. Well, isn't that better? Look at that. It's readable now. Look at that. this is what you want to go for right here. And, oh, I did that too. Cool. Just make it look pretty. Yours won't go off the screen too bad. You don't have these long category names that I have right here. But now it looks a lot better. So with this, we're missing one last thing. The last thing we're missing right here, and this is a thing you have to do, is you have to go here to the second red arrow, and you have to go to this. No. Histogram options. Not histogram technically. We're off the screen. And right here, show counts. I like the counts better. Okay. There we go. So here we are. This is not your graphic. This is my graphic. How does this look right here, Sloan? Does this make sense? There might be a way. Can we order that? I wish we could. There might be a way to order this. I'm not a jump pro, as they say, but I'm better with R these days. But how does this make sense? We have a bar chart here. It does call it a histogram. This one thing I don't like about jump is it calls it a histogram, but this is technically a bar chart. Then we should write up about this correct. So we're going to go right here. We're going to screenshot it. Now, here's the thing. If you take a little extra on your screenshot, that's never a bad thing. But I'll explain why. The reason I say taking a little bit extra is not a bad thing is because you can always go here and crop your screenshot by clicking the picture, going to picture format and cropping it. You can always get a very exact screenshot right here. So you can get a much more exact screenshot by cropping it and get exactly what you want the screenshot to be. So that looks a lot better right there. Don't just take extra. This is the kind of screenshot you want right here. You don't want your taskbar at the bottom. You don't want backgrounds on there. You don't want extra things. Think about this in a presentation, like you're making a PowerPoint, and you would take this image right here, you bring it over to the PowerPoint, and this is where you would talk about it over here. You'd be like, okay, here's my graphic that I'm inputting, and you'd make a nice graphic right here. You'd be like, okay, here's our data, and then you would display that. You might even do it as a separate, like two separate things you had in a PowerPoint. But think about how it's going to look nice and neat. Does that make sense, Sloan, right there? Like all your screenshots should show only what you want to show, and this is the kind of screenshot you're looking for right here. So when you talk about this, all you're doing is talking about, yeah, nice job, Sloan, right there. Throw you some points. So what you're doing is you're going from the lowest to the next lowest to the next lowest to the next lowest, and that's it. And then you can mention there are 499 people who answered this question, but you'd be saying things like, of the 499 people, we observed that 5 of them were engaged or married. This is roughly about 1%. So this is the relative frequency if you times it by 100, and this is the count of the observations, as it says right there, the count. So when you're talking about the percent, which you could mention, they're right there. This is also known as p hat. Each one of those is the sample proportion. So that's a fun note for the future, the sample proportion right here. And the notation on this is x, and the notation on this is n. So if you really want to get ahead, these are notes for the future. Each of these are the counts of the observations. Let me highlight respectively. So all of these right here would be if we're talking about the occurrence of something, and the probability of something would be over here on the other side, the proportion or probability from a sample, and then the sample size is this right here. Just some notation to maybe take note of if you want to make sure to know this for later chapters in the class. X is the amount of successes, N is the amount of trials, and P hat is the sample proportion. You don't have to know that right now though. So should you include any of that really in your write-up? So Sloan, yes or no, or Andrew in the chat, and good job, Andrew. Let's throw Andrew some 20 points too. Should you include really any of this in your write-up? Is that kind of required at this point right here? That's some test 3 stuff right there. Do not include, just to be clear, do not include that in your write-up. Your write-up is simply not at this moment, correct? Does it make sense? Are there any questions on what you're going to write up right here, talking about in ascending order these values and what they represent? So right now you're just interpreting a bar chart and explaining the counts of the observations for each groups along with the percentages and making it clear to the reader what are the most likely or the most common and least common groups right here. Make sure to do it in ascending order. So go, once again, go in this order right here, lowest group to highest group as you talk about them. I got to also say a little more than, yeah. You might comment 50 but remember this, you're doing a different variable, but yes, you could say there were 278 people out of the 499 who were single, which is roughly 56%, i.e. a little more than half. I would probably quote the percent, but yeah, you might say, which was 55.7, roughly a little more than half. Because that's probably what, if you're summarizing for like your boss or something, you might say like a little more than half, around 55.7%. So you might quote the number because you can just write it down, but then you might put it in more general terms as like roughly. Probably my best advice here is when you give any of these numbers, probably give them all to one decimal and be like about 5.4. And then you could say, you know, if you're telling someone, say about 5%. But I would probably give everything to one decimal, and I'd probably mention both values if I'm talking about it. Like I'd probably say the count and then out of the total. Okay, so the good news is now that we've done this graphic, the pie chart is going to be very, very similar. So the pie chart is virtually identical work. So let's go look at that pie chart right here. Remember, a pie chart is just the univariate display of categorical data. So we're using the same variable right here. Let's talk about things people might miss on it. So the number one things that people will miss on the pie chart are going to be, oh, we're using Graph Builder now. So make sure to use Graph Builder. Not too hard to do that. So we're going to use Graph Builder. And we need to add labels. I'm going to label the value again. And then make sure to, ooh, this is a big one. Click Done. That's a big one. A lot of people don't click Done. So make sure to click Done. I'll show you how to do that. You just click Done, but a lot of people don't do that. You'll lose points if you don't do that. Take a screenshot, insert it, include a short write-up. You believe the best format to this. You know what? Maybe I'll do percent. I'm going to do percent instead. You can do either one. I'm going to do percent this time. But we're going to get the same graphic just as a pie chart. Okay, so let's take a look at this right here. So we're going to go to Graph Builder, make a pie chart, put percents in, talk about it, make sure to click Done. Here we go. Okay, back to our data. Once again, Brian is doing a different variable. Use your variable. Go to Graph Builder. This is where you can make graphs like that. So with Graph Builder, we click it, and now I'm going to take distance from campus this time. Once again, I'm doing a different variable because I think this one is not as crazy in terms of it is. Let me start over. I'm going to take, sure, family economic level. And so we've got here family economic level, which actually is an ordinal categorical variable because it has order to it. Lower, lower, middle, 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 upper, upper. And once you have your variable input here, I'll show once again, you just take the variable, you drag and drop, you're good to go. Just put it in the middle of the graphic right here. And with the variable in the middle of the graphic, you just click the pie option. Now you have a pie chart. Now, what have I failed to do? For 50 points, why is this not going to get you all the points? There's two reasons, actually. There's two errors if you start screenshotting right here. Really? There are two errors if you were to screenshot that. There'd be two errors. Can I? Thank you. There'd be two errors right here. Values first and foremost. Yes, we need some labels. So let's go here to label by percent of total value. Okay. I'm clicking it and hitting control if you have it selected, or you can go to rows, clear row states. That'll undo it if you have that selected. Rows, it's not the end of the world. That won't lose points. Okay, so we're missing one last thing right here. We're missing one last thing. So we're almost done. Click Done. Both you got right there. We got 50 points for both those answers. So make sure to label. I'm going to put the percents right here. So label by percent of total value. You do label by value. Don't do label by row. That's the row numbers that these things are in. That's the only one that'll lose points for you. We want either the percents or we want the counts of the observations. So I'm going to go percent right here because I don't have a total. So I want to talk percents instead. We're going to click Done right here. And then I'm going to make it look nice and pretty. As long as you click around here, you can change the full thing. And that's everything's showing. And you can actually, if you want, you could say family economic level. And there you go. So you can do that. Actually, you know what? I'm going to remove this. I'm just going to double click. These are not required. I'm just making it look prettier. And yeah. And now, you know what I'm gonna do? I'm gonna move the graph builder thing. I'm gonna get a really nice picture here. Well, wait a minute. Can I change this? Double click. Look at that. And you know what I'm gonna call? Legend. We're gonna call that legend. Oh, look at that. This is the best one we've made. All of those things I did right there are not required. I'm just trying to make my graphic look as pretty as possible. Okay, we're going to take a little extra, remember, because we can do the fine tuning of this when we go into our Word document. Got a really nice looking graphic right here. And once again, put this in one Word document. I'm just showing you right here a Word document with it in it. So now I'm going to click the picture, do the fine tuning of the cropping by clicking the picture, going to crop, and then just taking this down a little bit right there. Perfect. And bringing this up a little bit right there. Perfect. And that's the way I want it. Does this look like a pretty professional picture, well labeled, easy to understand? What are your thoughts on this? What do you think, Sloan? What do you think, Andrew? Would you be happy to display this in a report to somebody? Is this how you would want like a graphic in a report? Did you right click? Double click. Sorry about that. Double click. Thank you, Sloan, right there. Not required, but if you double click, I might have said right click by accident. If you double click it, it'll bring this up. Or if you double click or you just click in there, and I lost my access down here because I deleted it. But if you double click that, it should bring this up to where you can change this or you could remove things. A lot of little options, which is really great. Not required, so you don't have to do those extra things, but I do like to make my graphics look great. It's something I obsess about, is like really nice, great looking graphics that tell a person a story. So how are you doing right there, Sloan? Got your graphic. From here, we just talk about it. Maybe we'll talk about it in ascending order again. The lowest percent of individuals was 2.8% of students in the lower class. Go up from there. The next lowest percent was 7.8 in upper class. So we kind of have the two polar ends of the spectrum, lower and upper, at the far ends. And then you could go up and talk about the 9.6 there in lower middle. You can see the majority of students, 38.1, are in 38.1 and 41.7 are in middle/upper respectively. The vast majority of students fall into these two groups. Only about not even a quarter of students, no, less than a quarter, about a fifth of students fall into the extremes and lower middle. So yeah, pretty good right there. And so make sure to talk someone through this graphic. That is the goal, that you can explain this graphic, you can communicate what it's telling somebody, and the graphic should kind of speak for itself, but you need to do the write-up. So do not forget for any of these, your write-ups. I have a lot of students who don't do the write-ups, and you lose a ton of points. So mention the values. I'm going to highlight here once again. You really want to talk about all the values. You're welcome, Andrew. Yeah. Talk about all those values. And this is what we do right here, is we make sure we understand how to make great graphics, how to interpret them, how to communicate ideas, because that's what all majors need. All degrees need to be able to communicate and understand data these days. That's what we do, is we work with data. Okay, we're on to the histogram. Let me take the note right here for people watching in the future. And then we're going to do some chapter 2 homework right after this. And Sloan, we could do some chapter 3 homework. I'm dropping things on the ground, though. Whee! My headphones going out of my head. Okay. So this is at the 39:53 mark. Stats 201. Data analytics 2. Histograms. Histograms. In the description, is it better to start low? Yeah, you could. There's no requirement for this one. Just says do a write-up you believe is the best format to inform the reader about the data and why. Just go through informing them. Probably low to high like we did with the last one. You could say this one is being, yeah. There's no, it doesn't give any additional details. And we could double check the write-up. Bar chart or pie chart write-up is accurate and matches format of the instructions. Yeah. Write-up is accurate and written in complete sentences. I've seen people not turn in complete sentences. Like they just turn in bullet points like lowest this, mid this. They don't do complete sentences. So do complete sentences, don't do bullet points, and in a paragraph format. So if you look where the full marks is at, write full sentences, don't do bullet points. I've seen people lose points on that right there. So just rubric's going to help out. Create a histogram. So we're going to have to use a what variable right here. We're going to have to use a what variable to create a histogram. Remember, Brian's going to do different data every time. We're going to have to use a what variable to do a histogram. So by nature of it being a histogram, we're going to have to use a what variable for our example right here. What kind of variable do we have to use for histograms? Histograms require what kind of variable? Good review of our topics to know a histogram, a box plot, a dot plot, a stem and leaf. All of these require great job, Sloan, right there. That's 50 points. Univariate quantitative data. So here's the one variable, meaning it's univariate and it is quantitative. We're just asking people, multiple people, how many credit hours did you take this semester? So univariate quantitative data, perfect answer. We need to put it in horizontal layout. Same thing we did last time. We need to have account access on it. We'll have to add that in. Take a screenshot. We need to include the histogram, the quantiles, and the summary statistics. That's easy right there. And put it in your Word document. And then we need to do a short write-up where we identify the shape, dun, 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 very important, and provide only, okay, this is where people make mistakes, only the appropriate measure of center and spread. So with this, be sure to include the corresponding values for center and spread. Do you think the maximum values might be considered an unusual value? Ooh, that's a new addition. Maximum might be unusual. Okay, so this is a new addition right here. So I wouldn't have noticed that had I not read the instructions. Okay, so we've highlighted where I think people will make mistakes. Please include the why or why not. That's also super important too. But here's the thing. When we do histograms or quantitative data, the very first thing we always talk about is what? So let me go here to lecture time. So when we do histograms or quantitative data, the very first thing we talk about is what? The shape. So we really have what is considered like normal or kind of symmetric. So you could have right here symmetric like this, or like normal, and this is all under this umbrella of this group right here, where over here you have things that are skewed or maybe have outliers. So you could have data with skew or outliers over here on the right. I didn't have a lot of room to write, but you have kind of more normal symmetric data that doesn't have extreme skew or outliers. Then you have skewed data. So does that make sense? You've got two types of data. Type of data number one, type of data number two. So you have more normal data, could be kind of more uniform too. That's not normal, but it's doesn't have skew, doesn't have outliers. And then you have skewed data. So we could say skewed, not skewed. But the thing is, if data is skewed, it will drastically impact the what? This is a great question for the test. Skewed data drastically impacts the what? What would skewed data drastically impact? We always do a little bit of theory here. Skewed data drastically impacts the what? Boom, Sloan. Great job. And that's why we don't use the mean. Also, skewed data drastically impacts what else? Type 2 letters. So think about, we don't use the mean because the mean is drastically impacted by it. And we'll show it right here. So if I were to go here and make up some fake data, I'll do it in jump so you can see it. That way people who love some jump can be like, ooh. So here's skewed data. We got 1, 1, 1, 1, 2, 2, 2, 3, 3, 4, 5, 8, 9, 18, 100. There we go. This is skewed data right here. Let's go to Analyze, Distribution, just some quantitative data, and you can see the extreme. Is that right or left skew? Is this extreme right or left skew? Got to draw a monster man. Is that a right or left skew distribution? We have a saying. It is right skew, Sloan. Great job. Right to the high, left to the low, whatever way the monster man's tail goes. Right to the high, left to the low, whatever way the monster man's tail goes. So if you look at the median right here, the median is 2.5. The mean is 11, basically 11. The standard deviation is 26, which is a large spread, but the IQR, which is the range of the middle 50%, is only what? Can you calculate the IQR from this? Jump will do it for you, so we can cheat and get our IQR by going here. But think about what the IQR is if you're looking at the data right there. It's the range of the middle 50%. So a lot of people know how to get range. The range right here is 99. So what's the range of the middle 50%? It contains 50% of the data. Yeah, it's 5. There it is. Q3 minus Q1. Formula right there. Just like max minus min, big number minus small number. Now, if you're worried if you got it wrong, you can just go here to the customized summary statistics. You don't have to do this, but you can check your work with customized summary statistics. We can go here to the interquartile range. And I'm also going to turn on skewness and watch this. You can actually tell it's right skew because right skew is positive skew because it's towards the higher numbers. So if you want to get something or see if something's skewed, you can actually check the skewness. Now, one last question right here before we start doing the full analysis. This is kind of the theory portion of talking about histograms. If something were to be symmetric, like let's take this data right here. This data is what we call symmetric because you can fold it over on top of itself. Just take a guess. This is a more advanced thing. What do you think the value of skewness would be for something that is symmetric? If we were to quantify the skewness of a symmetric distribution, the skewness would be close to what? If we were to quantify the skewness of a symmetric distribution, the skewness would not really be positive. Yes, Sloan, you got it. It'd be very close to 0. Exactly. So if something is left skew, so if we have here left skew data, so here is going to be, I'm going to store this as X for the moment. It's just easier for me to make it over here. Does it make sense? This is left skew data. So the skewness of this should be what, Sloan? Since it's left skew data, you draw your monster man. Here's a left skewed monster man. So the value of skewness should be what? Like if you were to quantify skewness, the value of skewness is probably going to be what right here? If you were to quantify it, which we don't do in tool 1, but people say, well, how do you know it's left skew? I can calculate the value of skewness mathematically. Since this is left skew and it goes towards the negative numbers, the monster man's tail, the value of skewness is a negative skew. So it goes towards, oh, you might say, well, oh, so it's not the number exactly. That's not how this is calculated. So watch this. Let me do the following. This will have similar negative skew. I'm going to go here and just add 100 to these values. And now there's the same histogram. Do you see I've just moved the center of it? And so it still has negative skew. This one's actually more skewed than the last one. And you can kind of see it because that little pull on the end. This one's more skewed. It has a little more pull. So we just say it's negative skew. So you will I've never calculated that by hand. It's just if something's symmetric, it's going to have like 0 skew. If something's pulled to the right, it has positive skew. If something's pulled to the left, it has negative skew. So that hopefully brings more context on why we say right to the high, left to the low, whatever way the monster man's tail goes. So his tail is going towards the low side here, which is the left side. So going to be very important we know the shape. When we talk about shape, make sure to comment on these things. Frankly, you should be able to write 2 to 3 sentences on the shape of something. Let's try to do that. Your variable is going to be, make sure you're still using your 499. Your variable is credit hours. That's the one I can't do. Anything that is what color Brian can pick right now and jump, except for that first one. Anything that is what color Brian can pick. So now you have to know a little bit about jump to be like, these are the quantitative variables in jump. Anything that is what, except for the identifier at the start. So we don't really graph identifiers. Anything that is what color Brian can pick. How do I know a variable is quantitative? And I'm not going to pick credit hours, which gives it away. Anything that is what color? Blue. So I'm going to click the languages students speak. So with languages students speak, I've already clicked it, which is a good thing to find your variable. Because now that I've clicked it, I can actually just click Y columns. If you don't have it clicked, you can just drag and drop. So whatever way works for you, you can click and click Y. But if you click it over there, you can just click it right here. So now we're going to click OK right here, and we get our distribution. Very clearly a what distribution. Very clearly a what distribution here. Very clearly a what distribution. Very clearly a what distribution. Here, I'll do the next set in a moment. But very clearly, I can see right here. And be careful, is this left or right? And this is where people might make a mistake, especially if you don't put it in horizontal layout. Very clearly a what distribution. And don't worry about getting anything wrong, because we'll throw points just for thinking about it. It's very clearly what skewed. Remember, I was saying right to the high, left to the low, whatever way the monster man's tail goes. There's a common mistake people make when looking at this. So I'm hopefully saving someone on the test if we put a question like this and you're like, wait a minute. Right, exactly. Great job, Christian, right there, jumping in with the answer too. It's tricky because if you drop it to the side, you'd be like, well, it's left skew because it's going to the left side. But the number line would be reversed. It's pulled towards the high side. So we have to go here to the top right arrow, go to stack. It's top right arrow, stack again, puts in horizontal layout. I'm going to stretch it here once again. And then you want to go to the second red arrow, go to histogram options, and count axis. I'm pausing right here. Make sure you go to the top red arrow, click stack, go to the second red arrow, go to histogram options, submenu, count axis. This is what is required for it so that you have everything displayed here properly. You can do additional things like going here and going to histogram options. And where's the color? Display options. Wait, where's color histogram? Did I believe it was there and it's not? You got a display option. Well, I'll be histogram color. You right click it. I'm going with a nice purple right there. So if you right click it, you can change the color if you want. Not required. Once again, we can change anything right here. I think we can even change those. We don't need to. Okay, so we have the quantiles. We have the summary statistics. What does all of this mean? There is one individual, and I think it's only one right here, one person who what? One person who what? And we can double check it's one by highlighting the point. It is one selected row right there. I clicked in the blank space. There was one person in our sample who what? Kind of. They said to us, I speak 4 languages. We could go and look at this individual right here. These are not the required things, so keep your graphic up while we do this. We could go right here and talk to that individual by finding them. Here they are right here. This is, I'm going to deselect. Let me go. Oh, darn it. Where'd they go? High school GPA 4. 4 languages. Here we go. They are male. They live on campus. They have a 4.0. Yeah, they speak 4 languages. I'm not shocked. They read 26 hours a week. They're pre-pharmacy. They have 13 credit hours. This is all their information. Weed should be completely legal in their view. They carry a refillable water bottle. They don't use tobacco. They have not been arrested. All this good stuff right here. Okay. So that is a person who answered our question. Then we got some people over here. 10 people speak 3 languages. We have 53 people speak 2 languages. Does that make sense what these bars are? And you can see the counts of the bars right here. A lot of people in our data set, what? A lot of people in our data set, what? A lot of people in our data set, what? A lot, 435 people to be exact. A lot of people reported what? You can see it over there by the count too. A lot, we just have to know what we're looking at. Speak 1 language. Everyone right here has a language starting at 1 going up to 2 and slow and good answers. Does that make sense? This is somebody who said they speak 1 to 2, but 2 is in the next bin. So anyone who answered 1 up to 2. Now this is also discrete because you can't speak half a language. You either speak a language or you don't. So these are all people who speak 1. Now it does not include 2. I think it showed it right there. It said like 1. You see it has not including 2. That's the like not including. It starts at 1. Languages inclusive of 1, but up to 2, not including 2. So the next bin right here is the bin starting at 2, including it, not including 3. So is there anyone who speaks 5 languages in our data set? So look at this bin right here. Is there anyone who speaks 5 languages? There is one individual in this bin who said, I speak 4 languages up to but not including 5. Was there anyone who said they speak 5? No. So a lot of people get confused because they say, wait a minute, that goes up to 5. Well, if you look at the box plot, this is a box plot up here. It doesn't show any dots right here, no outliers. So there is, and great job, Andrew, right there. There was no one who speaks 5 languages in our data set. It's just that the bin goes up to that. Here's the thing. Bin widths are completely subjective. What is the bin width here? This is a horrible bin width. What is the bin width here? Don't do this to your histogram. What is the bin width now? What is the bin width now? It's completely subjective. The box plot did not change. What is the bin width there? Don't look at the number line. Look at the width of the bin. What is the bin width there? Don't do this to your histogram. The bin width is what? It's just the width of the bin. How wide's that bin? That bin is, so I'm talking about this distance right here. How wide is that bin? Good guess. It's actually 4, because it goes from 1 to 5. Does that make sense? So from 1 to 5 is 4 units. So if you look, you just go across here. So Sloan, good guess right there. What is the width? What are the widths of... That's weird bins. What's the width of those bins? So just so you can understand, like a bin width, which I'm just changing. It's the same data. I'm just changing how we compile the data into these bins. So what is the width of those bins right here? So you just want to think how, don't look at the number line and be like, it's 1. Look at the width of the bin that collects the data, because all these data points go into the bin right here and make the bin go higher. 2, great job, Christian, right there. So it's 2, yep. So you see, this is all the same data. I'm not changing the data set, and it changes like how many observations are in each bin. Don't worry about changing the default right here. It'll be fine. What is the number one thing? And this is where we're going to start interpreting it. Let me call that section of the video histogram theory, because I'm sure someone watched that and is like, that didn't help me. So making/theory. Okay, this is the analysis portion. What is the first thing we need to do when talking about this? What is the first thing we need to do when talking about this? Whenever we talk about quantitative data, we have to talk about the what first. Whenever we talk about quantitative data, we have to talk about the what first. Whenever we talk about quantitative data, we have to talk about the what first. Goes in this order. Goes in this order. When we talk about quantitative data, the first thing we talk about is always... Well, so we'll talk about the center next. We have to make sure we know the shape. So good answer, Sloan, right there. We'll always talk about the shape, and then the shape will tell us the appropriate center and spread. So, but we've kind of already talked about the shape, but let's make sure it's very clear. Here is everything Brian would write about this histogram. We asked 499 students how many languages they speak. The values of languages range from 1 to 4. There is a very clear right skew to this distribution, where students commonly spoke 1 language and very few students spoke 4 languages. In this distribution, we see that anyone speaking more than 1 language is an outlier, and that's pretty unique right there. So the people who speak 2, 3, and 4 languages were considered outliers. It's kind of unusual. Did you hear that? I'll do another version of it right here, but this is everything I would write up. We spoke to 499 UT students. We asked them how many languages do they speak. The distribution came back very right skew. A lot of students spoke 1 language, and then the students who spoke 2, 3, and 4 languages were considered outliers and unusual. So I might even say, like, I think speaking 4 languages is a very unusual thing, especially for college students. And unusual doesn't mean bad, it just means uncommon. I would maybe comment on that. Like, people think unusual. Oh, unusual, that's bad, right? And it's like, if I make $1 million in a day, that's very unusual. It'd be a very good thing. So right there, remember, unusual doesn't mean bad every time I say unusual. So that is how I would talk about the shape. And, oh, I might say unimodal. Unimodal. Ooh, throw some unimodal in there because of the modality. Throw unimodal in. It's unimodal, right skewed. Exactly. Very impressive. We could say it's very unusual because it's very impressive. Throw some good connotation on it. I like that. Good answer, Sloan, right there. Throw your thoughts on it. It's very impressive. Very unusual because it's very impressive. Unimodal, right skew, extreme outliers, good stuff like that. Use full sentences. And if you're thinking about what to talk about, when you go back to the shape discussion in the notes, remember you've got a lot of different things to talk about shape right here. We're just going to go show the notes again. You can talk about the modality of it. Mine was unimodal. There's bimodal, multimodal. Yours might be uniform. It could be symmetric. And then there's skew. It could have outliers and gaps. So that's how you talk about shape. So refer to the notes and use keywords like gaps, outliers, skew, unimodal, symmetric. Use what words apply to your data. Now we have to talk about the appropriate measure of center. For me, what is the appropriate measure of center? For me, what is the appropriate measure of center? For Brian, what is the appropriate measure of center? For me, might not be for you. For me, what is the appropriate measure of center? For Brian, what is the appropriate measure of center? The median, Christian, great job right there. The median is the appropriate measure of center because Brian had skewed data. Yours might be more normal. If you say it's normal, use the mean. Now, here's the thing. Don't report everything. report only the appropriate measures. So make sure you see right here, it says provide only the appropriate measures. So if you are skewed like me, if it's skewed in one direction, report the median for the center. If it is skewed, what will you report for the spread? If it is skewed for the spread, you will report the what? So now we're down here in spread. If it is yes, the IQR, the interquartile range. And I guess we might talk about those briefly here, but let's just show how to get those. To obtain these values right here. And so I'm going to do a short write-up on those by talking through it. The median was the, so you don't want to just say the median is this. The 50th percentile of students spoke one language, i.e. 50% of students speak one language or more, or 50% of students speak one language or less. That is the median, which represents the 50th percentile of the amount of languages students speak. Does that make sense? What is the median? It's the what again? Like the median is always the this, which we don't just say the median was 1. We'd say, and then we give it context, the what percentile of languages students speak, because that's what we asked. The median is always the what. The median is always the what. The median is always the what. The median is always, always, always the 50th percentile, but then give it context. The 50th percentile of languages students spoke. Do you know what? Who can calculate the IQR, which is just Q3 minus Q1. It's just the range of those values. It's kind of the middle number. We usually call it like the 50th percentile. So it is the middle number technically. Got 3 points for that. But we usually interpret it as like the 50th percentile, which is the middle number. So, but we might say, you know, the 50th percentile of students, you know, the kind of middle person. You might say middle person. That might help people. And Sloan, great job right there figuring out the IQR. It's 1 minus 1, which is 0. What does that tell you about this data? It really does not have much what to it. Since the IQR is a measure of this, it tells you there's not a lot of what to the data. Think about this. The IQR is a measure of this. And be like, there's really not a lot of what to that data. And you kind of see it. The IQR measures this. It tells you a metric of the kind of the what of the data. It's a metric of what? Shape, center, what? The IQR measures the what of the data. Well, we use it because it's skewed, but the IQR is how we talk about the spread for skewed data. It's a measure of spread. Does that make sense? So think about this. This data is not that spread out. Does that make sense to say that? Like to say like the IQR of 0 is basically saying there's no variation in the middle 50%. When you look at the middle 50%, it's a lot of students speak one language. So many that the 75% of students speak one language or less. 25% of students speak one language or less. Frankly, the vast majority of students speak one language or less. Pretty much only outliers speak more than one language. Does that make sense right there? There's really no variation in this data. There's just people who speak more languages, and that's pretty impressive if you speak more than one language here in America. I say that because, especially America, like if you're in European countries or you're in like Japan or China, it's more common to speak multiple languages a lot of times. One of my friends who came here to the U.S. from China, like to do college here, I met him on his second day in the U.S. And he was like, "Oh, hi, I'm Chu Yi." And I was like, "Oh, hey, Chu Yi." I was like, "Whoa, wow." I don't know. I was one of the first friends I had from China. I was like, "Whoa, oh, wow. How long have you been here? Because your English is really." I would speak differently to someone. This is 19-year-old Brian meeting one of the first people he's ever met from China, and I was super impressed, and I didn't realize that a lot of people in other countries actually grow up speaking English. And I will say this, I watched a video about Japanese culture, and they said they like for foreigners to try to speak the language in Japan, at least some people in Japan. It's not everyone in Japan, obviously, but I was listening to, because I really want to go to Japan, I was watching a video on like complaints people in Japan have about tourists who come to Japan. They said sometimes they're listening to like music loudly, they're drinking in public. One guy was so nice, he was like, foreigners, they're very different. They can vary just like Japanese people can vary. He was like, I was like, you're the best person I've ever, I don't know, you're awesome. He was very supportive of everybody. But with that said, 41-year-old Brian would speak very differently to somebody now with his understanding of kind of the world a little bit better. And, you know, but thank you to Chu Yi, who's a good friend of mine, but definitely informed me a lot of different cultures, different things. Anyways, I want to go to, yeah, check out Only in Japan. Really great channel. That's the channel I've watched for a very long time, Only in Japan. And then let's finish this off here. But YouTube, Only in Japan. He changed the, let me see here. Is it Only Japan Go? Here it is. This is one of my top favorite channels. Shouts to him. John Dobbs is John's his name. Where is it? John Dobb, right there. Yeah. Only in Japan. Check out his channel right here. Only in Japan. Really great channel. Really fun. Streamed 2 years ago. He does a bunch of live streams still. 13 hours ago. Yeah, he's so awesome. I actually like donated to him on a live stream, and he gave some advice about going to Japan to me. But he's got a really interesting background and everything, and does really great videos. But check out his channel. Really great stuff. Wild Grape. Oh man, don't copyright claim me.
Sorry, but that was probably what.
Man, I don't know. I hope I would just go out to a public area. I'm not gonna like, and I just see him like, oh, Only in Japan. He'd probably be like, hey, he'd probably be live streaming. I'd be like, I came to Japan. But I think Japan's opened up tourism again. So check out his channel. Really great stuff. And try to understand other cultures, especially if you go to them. And just because someone speaks a different language doesn't mean they're from another country. I think 19-year-old Brian didn't understand that, because you could meet someone and be like, they could be like, I've been here my whole life. Like, funny enough, I'm first generation American on one side. A lot of YouTubers just go to foreign countries. And yeah, it's so cool. Experience the world. Get to know others. And yeah. Anyways, Brian's gonna, yeah. So the biggest thing here, we kind of got sidetracked and had a little bit of fun on the histogram right here. The biggest thing is when it comes to interpreting the histogram, your histogram could be more normal looking. Let me go take a look at it real quick. I'm going to cheat. Let me go to the data. Let me go look. You're doing credit hours, right? Yeah. We won't interpret this too far, but what's the biggest thing that just jumps out right here? What's the biggest thing that jumps out? I'm not going to go too detailed on this, but I just wanted to take a look at yours. What's the biggest thing that jumps out right here? You need to mention this. There's something just like, whoa. Like, first thing I see is what's here. First thing that jumps out to me that I would need to talk about in shape is what? I'm trying to give you hints for your assignment. The first thing that jumps out to me is what? This is like huge hints if you stay till the end right here. First thing that jumps out to me is what? Like, first thing that just like, it is unimodal. That's where the peak is at. Sloan, good answers. But then here I'll point, no, which kind of gets to what was mentioned at the end right here. Yeah. So 22, that someone reported, at least one person, we can check. It was just one person. If you highlight it, you can check. I don't want to go in too great a detail on this, but I mean, what do you think, Sloan? Like, what does that mean? Does it make sense why I'm asking, like, what does this data mean? What does this represent? What is this telling us? Like, what does that mean right there? Because that's what the question really is getting at. And is that unusual? We don't want to go in too great a detail on it. So you might say there's what's in this distribution. You might say there's what's. I think I put it on the other notes. You might say there's what's in this distribution. Put in like a million notes. You might say there's what's in this distribution. You might say there's what's. I'd be like, you know, there's definitely... Yeah, there we go. That's the one I wanted. You might say there's what's. I'll definitely mention it during both classes today. You might say there's what's. Here, I'll highlight it down below. And technically on both sides, you might say there's what's. Outliers. Outliers. So definitely mention that. So because of outliers, that should kind of lead you down a path. Just dropping some hint. Is there anyone pick up what I'm catching right here? You pick up what I'm dropping right here? Does that make sense? Can I get a yes or no in the chat? Do people pick up what I'm dropping right here? What information I'm trying to help you out? Yes, sir. I like you gotta say sir. I like that. I see what you're getting at. I have to see what you're getting. Remember, only report the appropriate center and spread. Only report the appropriate center and spread. With that, I mean, we've basically done it. All it is about interpreting data. If you have outliers or heavy skew, now let me ask you this: where would this person lose points with their graphic right now? Where would this person lose points if you turned this in? So maybe you just saw me click those buttons really quickly. You turn this in. Where would the graders take off points for you? Like they're doing you a favor. They're helping you with your knowledge. You're welcome, Sloan. Yep. So I think you should be able to get a 10 out of 10 now, and hopefully we learned and practiced histograms of unique, very quantitative data. We talked about shape, center, spread, the modality of it, the skewness, the outliers, and there's one area the student would lose points on right here. If you look at the two things where we did the first one a little more slowly, the count axis. Don't forget your count axis right here. It doesn't say we need the numbers. I'm going to double check. There we go. Count axis right there. You do probability axis or count axis. Once again, this is found on the second red arrow, histogram options, count axis right there. I don't think it says label the numbers. Display options, count axis. Yep. And then finally, your screenshot, just people can see it again. Your screenshot should look the following way. It should have all that information right there. As it said in the instructions, you want the histogram itself, the quantiles, and the summary statistics. So that's got it. Any other questions right here about what's going on? Your final screenshot should look like this. Make sure it's nice and neat. Include all of them in the same document. You should be good to go. Well, I think we're going to do some homework right here. So that's got it. There's a screenshot you're looking for. Not exactly that one. Make sure you do your own. Make sure they all have the random sample size. Good to go. Okay, let's do a little bit of the homework. We can probably do the whole homework. Let's see. The orange peel. I went to a concert like 2 decades ago and gave them my email address. And I'm still getting emails. Still getting emails. Okay. If you have questions, let me know. Ma Pearson. Got class coming up here in a little bit. I think the first quiz was due. Instructor gradebook. Assignment manager. I need to email students this weekend. Usually either do it first or second weekend, trying to meet with students if they haven't completed work. Just want to make sure everyone's on track. Okay, we got it open. It was due last night. Okay, I got to see if anyone missed it. Let's do the first homework, replace questions. Okay. And so we're just going to do the homework in order right here. And let me take the note on what time it is. It is 1:14, fall to 3. There we go. Save and changes. And let's get started on the first question. Here we go. Okay, we're doing the homework right here, and we see a pie chart, which means we're looking at categorical data, more specifically univariate categorical data. Now, I want to make sure, take a picture of this if you don't have it, but this is going to be every graphic. We're up here in the top right quadrant with one categorical variable. Pretty much the Y variable of interest. We ask, like, why does a movie have a certain rating? So we make a bar chart from it, or pie chart. Pareto is a bar chart put in order. Frequency table shows the frequency of the observations. And a ring chart, we don't really love them. They're just a pie chart with the center cut out. We don't want a donut chart. We want the full. Give me back the center of my donut. So here's a pie chart right here. Is this appropriate display of data? Kind of an interesting question. The answer is yes, because if you collect, like, what was the movie's rating, a movie can't really have 2 ratings. So right here, yes, because each movie falls into one category. So that's how you would display it right there. Basically, more specifically, it's univariate categorical data. So I would say we don't want to make a histogram. I think good questions could be like, what's an alternative graphic you could make for this? A bar chart, a Pareto. You could show it in a frequency table. You could cut out the center and make it a ring chart. So good things right there. The least common group, NC-17. Your movie's probably not going to make any money right there. Limiting the audience, especially just one reason right there. But yes, and that's got it. To read a pie chart, I think most people know that, is you look at the frequency. It's really hard to tell. Bar charts are going to give you a better idea. The NC-17 right here is very close to I swear there's more G-rated movies than that. That many are? No. I know how box offices go. You get a lot of PG, PG-13. They're all centralized around that to maximize audience potential. So come on, Pearson, use some real data. I got some data on movies we could use. Pearson's great. We get a lot of good practice. I don't want to put down my Pearson, but yeah, I'm always like some real data is what we like to use here. A university teacher saved every email from students in a large introductory statistics class during an entire term. That's me right there. He then counted for each student who sent him at least one email how many emails each student had sent. All right. What does the accompanying histogram say about the distribution of emails sent? Okay, so he's looking at how many emails students sent as long as they sent one email. So really, you're just saying, like, how many emails did I get from students? Yeah. And then you just didn't count 0. So with this right here, we're going to see a histogram, and it's probably going to be right skewed because maybe they sent you, a lot of students just send you one introductory email, and then you have students who send you 2, 3, and then you have like a 10 or something, a lot of, and there it is right there. So there were 80 students, and this might be bin width of 2, 3, 4, 5, 6. Yes, there were 80 students who sent one email because this is from 1 to 2, not including it. And then there were 40 students who sent 2 emails. And then, I don't know, 15 students who sent 3. And you can see it's lesser, lesser. And then we have outlier over there at the far side, which might be 1 or 2 students. Hard to tell the height of the bin right there. I wish we could hover over it and it would say like 2 or 1. But there's just outliers. Okay. And we have to know if it's right or left skew. We have a famous saying here. We say right to the high, left to the low, whatever way the Monster Man's tail goes. So what I'm talking about right here is Monster Man here. And we draw the Monster Man, we put the tail. And when we say right to the high, this is the high side over here. Left to the low, that's the low side. Sometimes people refer to, I didn't want to print that. Sometimes people refer to the low side as negative skew and the high side as positive skew, but we're only looking at the Monster Man tail to figure out which way it goes. Once again, we showed more examples during the earlier part right here, where you can see this is a left skew monster person, monster man, monster lady. And you can draw it over here. And there is the monster person. Right skew, left skew, yep. And there's the monster. And it goes to the left side. But we did mention, and Sloan knows the trick right here. Great job, Sloan. 50 points for still being here practicing. Because you have to watch out. Let me throw you a trick. These are the common tricks you could see. And a common trick right here could be the following. Here's a data set. Very clearly a certain skew if you look at the data. But I'm going to try to trick you right here by giving you something that we don't normally see. So check this out in 2 seconds. This is a stem and leaf plot. The stem and leaf plot has a key down below saying 0-1 represents 1. So that is a person who answered 1, 1, 1. And you can see the answers over there. There's all the 1s. So there were 4 1s. There's the 2, 2, 2. There's the 3s. So those were the answers given. The 0 right here represents someone who said 10/0, which would represent 100. This is the first 2 leading numbers. This is the next number. There's 1 individual here. That's the person who said 18, which is all the way down there. So there's the person who said 18. Now, what way is this distribution skewed? So Sloan or anyone in the chat, what way is that data skewed? Be careful. This is where people often make a mistake. But remember, right to the high, left to the low, whatever way the Monster Man's tail goes. But there's a common mistake that people say, well, wait a minute. Right to the high, left to low, whatever way the Monster Man's tail goes. What way would this one go? You got a 50-50 shot at it. This is the hardest version of skew. But if you remember right to the high, left to the low, what way is this skewed? Give it another 5 seconds. Let's see if he'll answer. It is right. We can't trick Andrew right there. Because here's the thing. The common mistake is that when you look at this, a lot of times people will take it and they'll simply just turn it this way. And they'll say, haha, he is left skewed. But your number line is reversed. So you have to make sure you're looking at it with the number line properly oriented such that the high numbers, which is the bigger numbers 10, are on the right side. And now when we look at this, it's very clearly a right skewed monster man right there. So the high side, once again, has the right skew to it. If we look at a normal histogram that we usually look at, so here is the histogram, very clearly a right skewed data set. And once again, it's because the tail is pulled out towards the high side. Be careful. Sometimes people will just take this and flip it this way and be like, oh, it's left skew. But remember, right to the high. So because the monster man's tail goes to the right side, that is right skewed data right there. So it's right skewed. And we did mention one last way to check this is to go to the customized summary statistics and get the skewness right here in jump. And you can actually find out it has positive skew, which we mentioned over here, negative versus positive skew. It's a little more advanced. I like to mention these things. Pretty simple question, but memorizing it is important. This is very clearly right skewed. It was common for most students to send just 1 or 2 emails. That sounds right. It was not common for them to send, yeah. The common, it's definitely right skewed and common to send 1 or 2 emails. This is the modal area, the central area of the data, and it's skewed to the right. So that's how we would talk about the shape of it. Okay, we got another shape of a histogram here. Describe the shape. Let's look at it. Very clearly what? It's, are they going to say bimodal? It's a little, maybe. Seeing a peak here, seeing a peak here. Okay. I'm a little scared on this. Nah, that's another mountain. You have to say, if I were to go out and climb this mountain range, how many mountains would I be climbing? If I were to go out and climb this mountain range, how many mountains are there? And we could be a little more exact in our peaks. We could go. I think we've got a second mountain right there. So I don't think this is like, that's not a mountain. That's not a mountain. You really need clear peaks to talk about modality. That's more of a left skew, where there's more of a second mode. So this is like the central mode, and this is a secondary mode right there. So I think this is bimodal. Well, first thing we're talking about is skew right here. So it is definitely skewed to the left. So if we just look at Monster Man, he's a crazy looking Monster Man now. And you can see oh no, he's gonna eat the human. I'm in a weird mood today. Rawr. He's a happy Monster Man. He had lunch. He's not gonna eat. So it is definitely left skew. Once again, right to the high, left to the low, whatever way the Monster Man's tail goes. For those watching this question, just want to make sure you memorize this. Left is the low side, which is negative skew. Right is the high side, which is positive skew. A lot of times it comes down to repetition to memorize these things, so that is definitely left skewed right there. Okay, how many modes does it have? It does look to have 2 modes, and hence this is going to be the answer. 64 to 66. That is the central area of 64 to... Ooh, uh-oh. Is that a modal area? Yes or no? Is this area right here a mode? 64 to 66, is that a mode? Yes or no in the chat. So what this is going to clue us in on the way they see it, no. And this is how 2 statisticians can give different answers to questions, but that is not a modal area, which eliminates this answer. This is not an answer because 64 to 66 is not a modal area. So now we're down to, it definitely has modes, which are common areas. 74 to 76. Okay, 74 to 70, yeah, that's where the peak is. Okay, so 74 to 76 is this. There we go, right there. So 74 to 76 is the only mode. And make sure you kind of trace back to your data and be like, okay, that is, if you put the numbers down below, 74 to 76. And that's where they're saying the mode is at. You could say another statistician might say it kind of has a smaller secondary mode. It definitely has one strong peak. Does it have a second one? Kinda. So it all depends. It's interpretation. Modality, I don't think we have any ways to quantify modality. We just talk about where we see the mountains. And at what point is something bimodal? Well, the stronger the peaks between the mountains, like that's definitely bimodal. And this is not bimodal. So this is the yes. And this is the no. What do you notice about our graphic and the drawings I did? Like the top thing I drew is definitely bimodal. Like if someone told me that's not bimodal, I'd be like, what? What do you notice about our graphic right here? We're way more clear. We would throw you one up at the top or at the bottom. What do you notice about this graphic in the middle of these? So I'm trying to tell you something by putting this graphic in the middle. So the bottom graphic is not bimodal. This is not bimodal. That's just some outliers over here. This is clearly mode 1 and mode 2. What do you notice about our graphic here in the middle of these? What do you notice, which I'm trying to hopefully communicate right here, the idea of this graphic in the middle? Zoomed in too much right there. That graphic in the middle of these is what? What would you say? It's somewhere in the middle, right? It's not clearly bimodal. It's not clearly not bimodal. But one thing we can say with those answers is that this area it told us about is not a modal area. So that's how I was able to eliminate it. That is not a mode. If there was a secondary mode, it would have to be this right here. So it would have to return both those answers. So our questions will be very clear on the test. Just make sure you understand that modality is how many peaks does it have, and the stronger the modality, the more kind of we say it's modal. Okay, the accompanying histogram shows the life expectancy of 190 countries as collected by the International Health Agency. Which would you expect to be larger, the median or the mean? Very important concept right here, which we talked about earlier. The mean always follows the what. So let's do a data set right here. I like to do data sets in R just to show a little bit of coding. Coding's great. If you went to a company and these were the salaries, and at the company you heard that the average salary is $100,000. So let's go here to salary. The average salary is $100,000. Let me go to Saipan. The average salary is $100,000. What do you notice about the salaries at this company? The average salary at this company is $100,000. What do you notice about the salaries at this company? What do you notice about the salaries at this company? What do you notice? Look at the salaries at the company, and the average salary was $100,000. And here's a histogram. There were 6 observations contained within $0 to $200,000, not including $200,000. And then here's the answers for the observations that are contained in this bin right here. There was one salary between $600,000 to $800,000. Pretty much everyone at this company is making 0. There was one outlier over here making the $700,000. That's why the count is one individual. The count right here representing 6 individuals with making $0 is right here. So the median is 0. Boom. The middle number right here is 0. So we can get median is 0. That's going to be your 50th percentile of people right there. So it would be better to represent the center with the median. So what follows the skew? So this is right skewed. Which value follows the skew? So if we draw on top of this, we have right here a value here and a value here, and we have monster person. So which of those values follows the skew? So this is right here, right skew. Which of those values follows the skew? What value goes in direction of the skew? Which is what this question is trying to teach you, is that these values, both of these, we didn't mention the other one, but there's 2 values highly impacted by skew. Hence, we don't use them when data is skewed. What value follows the skew? This is the theory to answer the question. So if you're always wondering about notes, this value follows the skew. So it's right skew, so which value will follow the skew? Will the mean follow the skew or the median go in the direction of the skew? So I think we have the values over here. We just need to think about which value follows the skew, and then we'll know how to answer this question theoretically. So which value follows the skew? Good answer, 50 points. Remember, we throw. So the mean follows the skew. If you're looking for notes, right, the mean follows the skew. So remember, the mean was inflated because of the outliers at 100,000, and the median was down here at 0. If you look at the values, the mean's 100,000. So the mean follows the skew. Extreme values will impact the mean and the standard deviation. That's why we don't use the mean and standard deviation when it's skewed. Yep, Andrew, great job. 50 points follow-up right there. So if data is skewed, you don't use these values. You'd say, I don't want to use these values if the data is skewed. We only use it when the data is more normal and symmetric, either one right there. So don't use those values if the data is skewed because they will be heavily impacted by the skew. So that's going to help us answer this question right here. Let's look at the data. It's very clearly what's skewed again, left or right. Just boom, boom, boom practice. Left or right skewed. I'll draw your monster man here for you. This is very clearly the number lines correctly ordered, very clearly whatly skewed. Left skewed, great answer right there. So that means we could say maybe hypothetically, since it's left skewed, maybe we have a value here and we have a value here. Okay, what this first value is maybe what, and the second value is maybe what. The first value might be where the what is at. And it's probably a little closer towards the middle. The first value is probably where the what is at. This value right here. Where would that be at? Just like the thing we were doing a moment ago. That might be where the median is. Yeah, Christian, you got it. And then the mean will follow the skew. Does that make sense? So the median is where the middle of the data is at. That might be the middle, but the mean will be lower. It'll follow the skew. So the mean goes in the direction of the skew. Write that down. And so right here, the median will be larger. We can use our data as reference right here. So the median has a higher value because the distribution is left skew. So try to draw it out right here. We now have a picture explaining kind of hypothetically what we should see. And once again, these answers a lot of times you can just kind of put in what I put in, but the theory of the answer is more important, that you understand the mean follows the skew. Choose the correct answer below. The mean should be used. Oh, well, if data is skewed, what should we use? I can eliminate a lot of these answers. If data is skewed, what should we use? If data is skewed, what should we use for center? If data is skewed, we should use median. So it's skewed, or we use median because it's skewed. There you go. Lots of answers, but as long as you know when you have skewed data, use the median. So not too bad with that right there. Another student surveys members of their student club and finds that the balance on their credit cards is strongly skewed. Okay, so we're probably gonna have to figure out the right center and spread. She would be better off reporting which statistic as a typical. Well, the answer is clearly what? Now they're asking only about center. Let me ask it this way. What are your two choices for center? So don't worry about their answers. The only two answers for center are what or what. So, and I'll show the notes here in a second, but the only two answers for center are what or what. So what are the two candidate answers right now? What are the two possible answers? So don't worry about the right answer yet. What are the two possible answers because we're talking about center? What are the two ways? Boom, Andrew. Yep, median or mean. So we go back to our little chart right here. And so we're only choosing between median or mean. So now how would we choose? Do you remember what the question said? So we're picking between these two because we're talking about center. But what did the question tell us? So take a look at the question here again, and it gives away what we need to know right here. So that's going to be all the information we need. So it's definitely what as an answer. Definitely be like, yes. You can be 100% certain that the answer here is going to be median because it's strongly skewed. This is a measure of spread. This is a measure of spread. So this would be appropriate as a measure of spread, but it's a center. The median is a measure of center, as is mean. And we have lots of good notes right there on that. The company histogram shows life expectancy. Once again, click right here. And they want to know, would you report standard deviation or IQR? Well, so this is very clearly left skewed. So what should you report? Since this is left skewed, so we know, we could go with what we know. We know that it is skewed. So what should you report since you know it's skewed? And it's asking about the spread. Since it is skewed, the appropriate measure of spread would be what? Since it is skewed, the appropriate measure of spread would be what? The IQR. So think about the IQR. The IQR is the range of the middle 50%, right? So the IQR would not include what's. The IQR is the range of the middle 50%. So the IQR would not be impacted by what's. The IQR. Oh, great job, Sloan, right there. Yep, that's awesome. Get some Starbucks. What up, Starbucks line? The IQR is not impacted by what? Hence why we use it. It's only the range of the middle 50%. So the IQR is not going to get impacted by what's. The IQR is not going to get impacted by this. And that's why we use it. It's the range of the middle 50%. So just like our data over here, I could find the IQR for this. Outliers, Christian, you're on fire right there. We got to hit that 50 points. So I could find the IQR for our data over here, and then I could add in a crazy outlier like this, even bigger, and the IQR does not change because it's only the distance of the middle 50%, which is probably somewhere in here, which is not going to get impacted by the low numbers or the high numbers on the far end of the distribution. So that's why we use the IQR for skewed data. So it's skewed, so IQR since the data is skewed. Really good questions. I think Terry updated this, so shout outs to Terry. These are exactly what we need to know. A study of body fat of 250 men, measured on 12 body parts, the body fat they carry. Okay, would you report the standard deviation or the IQR? What do we need to look at for this? I'm going to wake up. If we want to pick standard deviation or IQR, we need to know the what of the distribution. Brian is going to have to do an analysis of the what of the distribution to start. Just one word. I'm going to have to determine the what of it to know if I should use standard deviation or IQR. The shape. Boom, Andrew. Andrew just got it, and so Christian too. Great job. So, I think this is more ish. I'm going to say it's ish this. It's a little ish. Okay, it's kind of, yeah. Let me do this. Let me do a reconstruction on it right there. There we go. Brian, so now it looks, I'll give you hints. I'm saying, yeah. Okay, what do you think? Ish. Something is. Ish. That extra bump I put in there is not there, but something-ish. I'll give you a hint more. Nothing's perfect in data. No data's perfect. This is a dot plot. We could make it a histogram by doing bars right here. So now it's a histogram. Or we could make it a stem and leaf by putting the numbers on it. Now it's a stem and leaf if I start writing the numbers instead right there. It looks mostly symmetric. I would say it's mostly symmetric. Nothing's perfect with data. It looks mostly symmetric. So since it's mostly symmetric, center and spread respectively should be what and what. Since it's mostly symmetric, center and spread respectively, because we're in the mostly symmetric region, center and spread respectively should be what? Like the appropriate center, mean and standard deviation, exactly. And then they're going to ask for which value. They're going to say, tell us the, should we use standard deviation or IQR? So standard deviation, mostly symmetric. I wish they said mostly. You better. Woo! Now, the other way it could have gone was IQR because it's skewed. I didn't see strong skew. Really, you got to look for a good inclination of this. These questions are fun right here. This is going to be, would you expect the distribution of a variable to be unimodal, uniform, or bimodal? So just so we can understand what these things mean right here, we have right here the idea of uniform. So uniform is going to be a flat distribution. It doesn't have to look perfectly flat. In theory, a lot of times uniform might look more like this. So that's the perfect view of it, and that's kind of what you see sometimes. It's mostly uniform. Unimodal, in the perfect world, it looks like this, but in the sometimes world, it might look like that. Bimodal, in the perfect world, it looks like this. In the sometimes world, it looks something like that, where you see it. So we have theory, what you would expect. It's like expectation, reality. I'll put that right here. Expectation, reality. Expectation, expect. And then what you really see, reality right here. So there is the uniform, the unimodal, and the bimodal on kind of what you see when you actually look and say something is bimodal. Just if you have kind of two-ish peaks right there. So the bimodal being peak 1, peak 2. But in theory, you want to see two real clear peaks. So symmetric or skewed. Symmetric, once again, in theory, is going to be anything that looks mostly symmetric. And then a lot of times you see something that looks decently symmetric. It doesn't have to be unimodal to be symmetric. Skewed, once again, that's one you see really a lot of times skew and that looks like that, but sometimes you see something that looks like this. So data, just we talk about it on how it generally looks and what ideas we get from it. There's the expectation and reality for those. Once again, symmetric could be the uniform distribution is also symmetric. Like uniform is also symmetric. It just means you could cut it in half and do this. So now that we understand the terms right here, uniform means one form, unimodal means one mode, bimodal means two modes, symmetric means you can fold it over on top of itself, looks the same on either side, and skewed means pulled in a direction like that is right skewed. Let's talk about what we have. Knowing the terms is important. Speeding tickets. Probably a lot of students have how many speeding tickets? Think 18, 19-year-olds. Blank or blank speeding tickets. Probably a lot of students have blank or blank speeding tickets. We could go construct this data. Probably a lot of students have blank or blank speeding tickets. Frankly, we might have the data right here. Probably a lot of students have what or what speeding tickets. A lot of students probably have what or what speeding tickets. If we were to go to students and ask speeding tickets, probably a lot of students have what or what speeding tickets. Sure. Sure. You can get your license taken away. So here's what the data might look like. Probably a lot of students have 0, maybe some 1s, some 2s, and then we got the extreme, like, what are you doing? So if we were to graph this, this is very clearly a right skew. There's high outliers over here. And so a lot of students probably have none or a lot. Well, yeah, so there might be bimodality to this. Ooh, I wonder if they're going in that direction. I think at some point you're going to get your license taken away. I think it's going to be right skewed. Are they going to go for a bimodal? They could, technically. It could be like, either have like 0 or like 10. I think it's like a lot have 0, some have 1, few have 2. Because really, you reach a point where they take away your license. So you're probably not in this upper bound. So that might not be a perfect representation of what it could look like. I'm pretty sure we're going right skewed right here. It would be unimodal because there's a strong peak. A lot of students only have 0 or 1. And it's skewed because, so most data values are 0 or 1 with a few values much larger than that. So that's kind of where we went with that. Players scores number of strokes at the U.S. golf tournament in a given year. So if you look at the golf tournament, think about this, and we could go. I wish we could go get that data pretty quickly. Tiger, if you know anything about golf, Tiger Woods and a lot of people, I think 70 is usually par for a course. Maybe not every course is 70. You don't have to know that about golf. I see you gotta know a little bit. That's the bummer about this question. Only one complaint so far. Is a lot of people are going to score around like 68, 70. They're going to get like towards par. That's a common score. So the distribution is probably going to be built up around that. Like we talked theoretically, a lot of players are probably going to have a score close to like 70 or something like that, or maybe 68, 67. So we're going to be right there. And there might be skew to it because there is like no lower bound. No, there is a lower bound. You could get all hole-in-one. So the lowest score possible in golf is 18. Like you get a hole-in-one on a par 5. I don't think anyone's ever done that. It's too long of a course. It'd be a weird par 5. I'll just call it a par 5. It's going to be a putting green on par 6. I got a hole-in-one on par 6. Not official hole, though. The distribution would probably be user pro players. Oh, 68 right there. Good knowledge. Sloan right there. So it'd probably be unimodal, built up around that area. Now I'm a little worried. Okay, let's look at the things down here. No, every golfer score is not going to be above the mean. No. More golfers will score above the mean than below the mean. Every golfer will have a different score. No, that is identifier talk. Most scores will either be very high or very low. No, that's going to be bimodal. Like you're going to have like pros playing in this. So that's wrong because that would be bimodal because there'd be a high peak and a low peak, 2 modes. This is more identifier talk. This is impossible. Every golfer cannot score above the mean. That's just literally theoretically impossible because the mean's the average, so that just wouldn't mathematically work. So we have to change our answer because more golfers will score above the mean than below the mean. So because of this, what they're saying is more golfers will score above the mean would look like this. So 68 might be the mean, but then the median would be over here at 69. because basically you got your few outliers down here who are getting like awesome scores. Does that sound right to you, Sloan? Because the 50th percentile, the median, is 50% of people get above this and 50% of people get below this. I'm not drawing symmetry right there, where this is the mean, which is the average of all the golf players, and it's getting pulled in the direction of the skew. So the mean is going towards the skew. Exactly. So there's going to be, and let's look at their answer again, more golfers will score above the mean than below because there's going to be a few really awesome scores pulling in that direction. But then you got to be careful. Someone could get like a really, so symmetric has to go. It's skewed. This is our final thoughts on this right here, and they're pointing us to that with the answer. So there we go right there. That's how it has to look. Other answers were theoretically impossible. Weights of female babies born in a particular hospital over the course of a year. So this could be bimodal because of premature babies. But there's not a lot of premature babies, so that's kind of a skew. Let's look at what they say right here for the things. Some babies will be much lighter than the rest. Okay, sure. That's not good enough. Every baby will have a different weight. No, that's identifier talk. Most babies will have an average weight with about the same number of babies lighter than average as heavier. Ooh, so that's an answer for the what of the data being what. So think about this. If most babies will have around an average weight with about the same number being lighter than average and about the same number being heavier, that's implying what for the data? So most babies will have an average weight. That implies unimodal. With about the same on the left or right side of it, that implies what of the data? So we're saying there's like this peak in the center and then about the same on the right and about the same on the left. I think that's where we're going. Symmetry, you got it. So that's implying symmetry. Most weights will either be very high or very low. No, it's bimodality. There we go. So unimodal and right here symmetric should be right. Yeah. I really like these questions. Hair length right here. I have a very awkward hair length. I got like that not quite to shoulder hair length. I would say I have a unusual hair length for men, but nothing wrong with that. Unusual doesn't mean wrong or bad again. But the distribution would probably be, I would say, bimodal. You have the flow, though. Thank you, Andrew. Crack me up. The reason I say bimodal is because when you think about it, a lot of people have hair that is either kind of like, we'll draw a person. This is Brian's art skills. Here's person. Oh my gosh, I actually drew something that looks half like a person. And you're like, Brian, that looks nothing like a person. I'm like, that is the best I've ever done. That is the best. Here, I'll try a second time. You ready? Go person right here. Person. That's their. Ooh, there's their chin. Oh. There go person. There's their head. Oh, it's looking like Squidward. There's Squidward over there. Big brain Squidward. Okay. So probably what we see is a lot of people with hair sort of like this right here. Just some normalish hair. May see a mullet. Oh, you see that the mullets are pretty what? Oh my gosh. What? Okay, what? This, jeez. That's my real art skills. Mullets are pretty what? Mullets are pretty what? Here, we're going to just draw a circle. There's my normal art skills. Mullets are pretty what? You would say a mullet is pretty what? Got to make it a little shorter in the front, maybe. A mullet is pretty what? Think about the distribution where mullets are at. Here's long hair. Mullets are pretty what? Mullets fall into that kind of uncommon range. Brian's over there at the smiley face. So mullets are kind of in that uncommon range. So I think hair lengths are kind of bimodal, where you've got the people with the longer hair, people with the shorter-ish hair, and then you got the people like Brian Stevens right here with a half mullet already. So I really think we're going for some bimodality here. So it'd probably be bimodal. It probably might, and if you look at the way we drew it, it's pretty symmetric. Remember, bimodal can be symmetric right here. Symmetric to great job, Zachary jumping in the chat. Yep. Looks like it's bimodal. Looks like it's symmetric, about the same amount of people above and below, or at least in terms of the way it's distributed. You could fold it over on top of itself. Bimodal can be symmetric. Most of the students will have the hair length. No. Every student will have a different. No, that's identifiers. Most studies. Please tell me that the answer that's right doesn't have the typo. No, approximately average length. No, that's unimodal. Men's and women's distributions have different modes. Kind of true. And it's possible to have a very long hair, but hair lengths can't be negative. Okay. So they're not going for symmetric. What they're saying is there's a lower bound to hair. So this is bald right there. So there's a lower bound to hair. So you got that. You got Brian right there. And then you got this. So they're implying a what to this distribution? They're implying a what to this distribution? They're implying a what to this distribution? Skewness, exactly. So as we look at hair lengths right here and where there's kind of modal areas, but they're saying then there is a right skew to this distribution. So we have to change this right here. So the answers are really going to clue you in on it, on the way they see it. So since hair lengths can't go, once again, we have here, they stop right here. This is a hard stop. There's no one who has negative hair. You can only be bald, have short hair, common, a lot of individuals have that. Then you got maybe a small peak around Brian's hair. Good to see you're credible. Then you got a lot of people with kind of longerish hair and then super duper long hair. There you go right there. So really, there's no upper bound technically. Really, that was a fun question to do. Just thinking about theoretically and understanding what these things mean. Their answers really, the written portion of their answer really clues you in on what it is. So the Centers for Disease Control right here, we have the last question. Then we'll probably take a break and get ready for class here soon. It is reasonable to conclude that heart and respiratory disease were the cause of approximately 29%. So heart and respiratory. Fun topics today. Heart and respiratory. Respiratory and heart. Boom. So we just add those two values. 29.4. 29-ish%. The way they report this, at least the way they're doing in this table, there is no overlap. Yes, because there is no possibility of overlap. What? Oh, man, we did perfect. I said yes because there's no possibility of overlap. And I selected the wrong one. There you go. Now, one thing I want to point out, if you do get things wrong, if you were to get something wrong, we'll just take guesses right here, 40%. If you get something wrong, what can you do? Like, if you get something wrong, what can you do? Someone just say in the chat for 50 points, if you get something wrong, what can you do? If you get something wrong, what can you do? Very important to know this for homeworks, which stay open until the test. If you get something wrong on the homework, not on the quiz, if you get something wrong for 50 points, what can you do? Very important to know this. If you were like Brian here, you did the question, you made some errors. It happens every once in a while. We misread something. We click the wrong button. It happens. You get 5 attempts on the quizzes, your first attempt being free. But on the homework, all you have to click is similar question. So now I say yes, because there is no possibility of overlap with the way we're reporting this in the table. Get it right. And to get the percentage S not reported, we're going to add up those totals because they should add up to 100%. And we see here that there's 38.3% not listed. We could subtract that from 100. Oops. 100 minus that total. So I just totaled those up and subtracted from 100. We're going to copy that answer right here. And then when we look down at the bottom, we're going to see which one has the other. And this one doesn't, that one doesn't even have the other. You can see that's about 38% right there, which looks like what you calculated. And there you go. And that is everything on the homework. So hopefully people have done the homework right now. I might take a short break right here between office hours. But we did a lot today, a lot of fun stuff. And yeah, any other last questions right here as we head off? What? Credible Tube, good to see you here. What questions are there? Let me know those questions. We're going to head off here in a second, take a quick break. Let me see. I think I've saved everything in here. Looks like it's saved. Yes, Sloan, 30 minutes right here. We got some of the announcement, right? Can we go over the quiz tomorrow? Which quiz is it again? Is it the Canvas quiz? Canvas Content 1? Let's do that. It's Canvas Content 1, right? So I think we did it. We'll do it right here real quick. We still got office hours, right? Let's go get that Canvas content. Okay. Oh, my Pearson quiz 2? We probably don't. Let's do a one version of the Canvas content. We might not have enough time because I got to bring someone into the class today who's going to talk about study abroad opportunities. Let's do. Well, do you want to do a specific question, Andrew? You're here, so you get to pick. Andrew, which question would you like to do? Tell me a question on my Pearson Quiz 2 that you want to do. Your choice, Andrew. Whatever. Tell me the start of the question. We did some during Monday's office hours in the afternoon. You can always check the description to see what we did. But tell me a question you want to do and how it starts out. Let's go find that. You're here. You get to pick. If you are here in the chat, it's your choice on what we do. Always remember that. So if you're watching this in the future and we didn't do your questions, just join in and ask a question. Let's do one of them. Here, we'll pick one of them. We'll pick one that we like a version of something we didn't do today. So here is a type of question we didn't do today. So this question right here is having us report the summary statistics for chapter 2. Let's put the data in the accompanying table. Okay, we're gonna do this one. Chapter 2 quiz. The data in. There we go. So for this question, the number one way to solve this is with jump. Now, you also want to know what these values mean. We'll solve it in jump here in a second, but make sure you know that the mean is found by averaging all the values. The median is the middle number. Now, let's say you were to have 4 numbers. So we're doing practice right now. What would be the median of these 4 numbers? What is the median of these 4 numbers? Be careful, this is a tougher one. If you have 4 numbers, what's the median? So with these 4 numbers here, what is the median? If there's an even amount of numbers, there is no middle number. So what would the median be right here? 3.5, great job, Andrew. So this is usually how a test might look. You need to number the number or put the numbers in order and then find the middle number. So that is how we find the median. But if there was only 3 numbers, you now have an odd amount of numbers. So what would the median be of these 3 numbers right here? Very easy to remember. The median is the middle number, the 50th percentile. So the median right here would simply be what? It'd be 2. Boop. So the IQR is the range of the middle 50%. We rarely find this by hand. So if you had numbers like 2, 5, 8, and 10, this is where we can actually figure out the IQR right here is the 25th percentile to the 75th. And what would the IQR be here numerically? Yep, you can use a scratch sheet. Great job, Sloan, right there. Good question. What would it be? 6. So it's the range of those numbers right there. So we're going to use jump to find these values. The standard deviation is the spread of the data from the mean. The range is the max minus the min. Q1 is the 25th percentile. Q3, like 3/4, the 75th percentile. The interquartile range is the range of the middle 50%. So we're going to click right here and go to copy to clipboard. Once again, click this, copy to clipboard. Hit Control C, notice, or Command C on a Mac. Notice that it does not have a column name. Control C on a PC, Command C on a Mac. Now we're going to go over here to jump, and we're going to go to File, New, Data Table. I'll pause right here. File, New, Data Table. Once we go into File, New, Data Table, we're simply going to go to Edit, Paste. Edit, Paste. Oh, yeah. No worries. No worries. So once you get this pasted in, guess what you can do? You can simply go right here and go to Analyze Distribution. So if you pasted in the data, go to Analyze Distribution, click the Y columns or drag the variable over, and click OK. And then we go to Stack like we did for our assignment, and guess what you have? All the answers right here. You can even cheat, go to the red arrow right here and go to Customize Summary Statistics and go to the IQR. Now the IQR is going to be 47 because it's the distance that Q3 is away from Q1, 97 and 50. But you can cheat and find it right there, which is 47. How far are these 2 numbers away? There's the standard deviation, the spread from the mean. There's the mean. There's the median. There's the Q3. There's the Q1. So 97 is that. Oops. 50 is this. The range is, I think we can have it tell us the range. We can figure it out. It's going to be 140, but if you want to be careful, you can go here to Customize Summary Statistics and go to Range. Once again, know how to find range. It's max minus min. Oh, wait, there's the range, 140. I was like, where's that? Know how to calculate range. You need to know that. You'll need to know how to read jump output, Sloan. Good question right here. Like, we could give you jump output and ask you what the IQR is. So we won't ask you to use jump on the test, but you could have to know how to analyze jump output. So the more jump output you know and understand, like what is the mean, the average of the values, standard deviations, a measure of spread. Standard error of the mean is variation in the mean. The upper 95% confidence interval for the mean is going to be the upper bound for what we think the mean is at. It's 2 standard errors basically above. So I have a question about Pearson. What if we still aren't able to get into it past the 31st? Blessing, good to see you here. Please email me at bstevens@utk.edu. You should be able to get into it. Please email me. Email me immediately and be like, I'm having trouble getting into my Pearson. We've got a my Pearson rep. You want to make sure you have access to it. Make sure you've paid for it through the course, through inclusive access, or paid for it. Make sure you have my Pearson. A lot of the assignments are going to be done through my Pearson. Good question right there. Make sure you have access to my Pearson. The median is 68. And the mean to 2 decimals, I think it was 80.92, was it? Be careful. You might type it incorrectly in. And there we go right there. I think we did it. Yes. So good stuff right there. We're going to take a break right here and grab a little lunch. But this is how we solve the question. See you in 30 minutes. Yes. Relax for a little bit here. But Blessing, please email me as soon as you can. Be like, hey, I'm trying to log into my Pearson. You should have access with inclusive access, or else you'll have to buy access. But let me know if there's any issues. But you want to make sure you have access to my Pearson and you can do the assignments, because a lot of the coursework is done through my Pearson to practice and to calculate stuff. Until then, I'll see everyone later. Bye for now. Bye.